Hi class, this is Neil, and this is the second video in lesson 8. In this video we're going to learn how to convert between radians and degrees. And before we do that, let's just kind of talk briefly about where this idea of a radian comes from. So, as I mentioned in the first video, a radian is really just another way to measure an angle. Really what it is, by definition, is it's a unit to measure angles related to the radius. So in the diagram that you see below that definition, notice we have a radius drawn in our circle here. And we really have just cut that radius out, and now we're stretching it along the outside of the circle. And so 1 radian, as you see in kind of this last diagram, is equivalent to the angle whose arc is the length of the radius. So this red line here represents our radius, and the arc is kind of the angle formed by that radius length. So our definition of 1 radian, so 1 radian is equal to the arc whose length is the radius. That's kind of an abbreviated definition, but it's one that I think is useful. Now, if we wanted to think about, we all know that all the way around the circle, the angle formed by an entire circle is 360 degrees. And if we wanted to decide, well, what does that mean in radians, or figure out what does that mean in radians, well, that's really closely related to the definition of circumference. Circumference is the same thing as 2 pi times the radius. So in unit circles, where the radius is 1, the number of radians in that circle is 2 pi. So we come up with this very, very useful definition, really, or conversion, and that is that if we go all the way around the circle in degrees, we've traveled 360 degrees. That's the same as 2 pi radians. If we go halfway around the circle, or 180 degrees, that's the same thing as pi radians. So just keep this in mind as we look at the problems that follow. So first off, if I want to convert from radians into degrees, I'm going to use this conversion that I've come up with here to help me do that. So here we're given a radian measure, and we want to convert that to degrees. Well, the way that we would do that is we would take our radian measure, whatever it is. So we'd take our radian measure and we'd multiply that by 180 over pi. And that's going to give me my degree measure. Next, if I wanted to convert degrees, so that means I'm going from degrees to radians. Again, I'm going to use my conversion that I have here, and I would take whatever my degree measure is, and I would multiply that by pi over 180. And that gives me my radians. All right, so let's kind of see this in the examples that follow. So in the first example, I want to express 198 degrees in radian measures. So here I'm going from degrees to radians. So I'm going to be converting degrees. Let me take my degree measure, so that's 198, and I'm going to multiply that by pi over 180. All right, so here I'm just multiplying a fraction. I'm not going to convert that pi at all. I'm going to keep that in terms of pi. So I'll just put 198 over 1. All right, we just multiply that fraction straight across. So it becomes 198 pi over 180. Now, if we wanted to simplify that, we could, focusing really just on the numbers here. So first, if I see that, I might think to myself, well, 2 goes into both the numerator and the denominator of that fraction. And so if I took 198 and divided by 2, I get 99. If I take 180 and divide it by 2, I get 90. Now, if I look at that, I might say, oh, I think I can simplify that one more time. So 9 goes into 99 11 times. 9 goes into 90 10 times. So here I've kind of simplified that fraction completely. And notice the pi just gets tagged on at the end. Right, so 198 degrees in radians is 11 pi over 10 radians. All right, example 2. Determine the degree measure of theta equaling 5 pi over 9 and state which quadrant its terminal side is located in. All right, so here I am converting from radians to degrees. So I'm going to take this radian measure, 5 pi over 9, and I'm going to multiply it by 180 over pi. All right, so again, we're just going to multiply really straight across this fraction. All right, so first, again, I'm not really going to worry about that pi at all, but I can't forget about it in my answer. So I'll do 5 times 180, and it's 900. Let's bring the pi over. 900 pi over 9 pi. All right, what do you notice? There's a pi in the numerator and denominator, so the pi's cancel. And my final answer, if I just divide 900 by 9, is 100 degrees. Now, what quadrant is that in? Well, if we think about our circle, that's 0, 90, 180, 270, and 360. We're firmly in quadrant 2. All right, so we're in quadrant 2 there. All right, so in this problem set, you're just going to do really questions 1, 3, and 5. Okay, if you want to do more, you can for practice, but all that you have to do is 1, 3, and 5.